Okay, so we're going to be looking at our first AddMaths topic. This is completing the square. Now, completing the square is not in the IGCSE, but it is in A-level and also AddMaths. Completing the square is basically another way to solve quadratics. We know two ways to solve quadratics at the moment. We know how to factorize quadratics. We also know how to use the quadratic formula. Completing the square also allows us to easily find the maximum or minimum of a quadratic. We haven't looked at sketching quadratics, but when we do look at sketching quadratics, we'll be talking about completing the square. Let's begin with an example, something simple like x squared plus 4x plus 4 equals 0. So we might be asked to solve this question. To solve this question, we might factorize. It factorizes as x plus 2 all squared. Okay, so notice that x squared plus 4x plus 4 is the same as x plus 2 all squared. Okay, we'll be using this fact later. Next, to solve this, we could square root both sides. This gives us x plus 2 is equal to 0, because when you square root 0, you get 0. Okay, so this means that x is equal to minus 2. So this would be the solution to this equation. Okay, so let's look at a more complicated equation and see how we would use completing the square to solve it. So we're going to look at x squared plus 4x minus 3 equals 0. What we're going to do is we're going to change this x squared plus 4x. Okay, we're going to write it. It sort of looks a bit like the first example. The first example was x squared plus 4x plus 4, and we've just got x squared plus 4x here. So we're going to change that. We're going to make it x plus 2 all squared. Now, where we had x squared plus 4x plus 4 before, we've now only got x squared plus 4x. So, we're going to subtract 4 from x plus 2 all squared. Okay. Now, what I've written in red, x plus 2 all squared minus 4, is the same as x squared plus 4x. We're going to check that this is the case. Okay. So to check this is the case, let's look at x plus 2 all squared minus 4. We're going to expand these two brackets, giving us x squared plus 4x plus 4. We still have this subtract 4 here. And the plus 4 and the minus 4 cancel, so we're left with x squared plus 4x. So indeed, x squared plus 4x is the same as x plus 2 all squared minus 4. Okay? So I hope you're happy with that statement. Looking back at the question we're solving, we still have this minus 3 here. Okay? So now what I'm going to do is I am going to simplify. So I get x plus 2 all squared minus 7 equals 0. So at this stage, this particular form of x squared plus 4x minus 3 is called the completed square form. I have now done what we were saying. I have completed the square on this quadratic. Okay, so you have to turn it into something squared plus something. So x plus 2 squared minus 7. So you've completed the square. Okay, at this stage we could now solve this equation. So what we could do is we could say x plus 2 all squared is equal to 7 by adding 7 to both sides. Next you could square root both sides, so you could get x plus 2 is equal to plus or minus the square root of 7. So when you square root both sides, you have the square root of 7. When you take the square root of 7, it's going to be plus root 7 or minus root 7. And then at this stage you could subtract 2 from both sides, so it's minus 2 plus or minus root 7. This would be the solution to the equation x squared plus 4x minus 3 equals 0. We could, of course, have solved that equation using the quadratic formula, or, well, we couldn't factorize it, so we might have had to use the quadratic formula. But we could have also done it using completing the square, which is what I've done there. Okay, we're going to look at a more complicated example now. So we're going to look at the question, write minus 3x squared plus 4x minus 2 in the form p brackets x plus q squared plus r. This question is saying, complete the square. Okay? We're going to use similar methods to ones we've just talked about, and I'll go into a little bit more detail about shortcuts to those. To start with, though, I'll write the question first again. Now, I've changed the question, so where I've written minus 3x squared plus 4x minus 2, I'm just going to change that to be a plus 5. Okay? So, what we're going to do in this question, to start with, we in the previous question had something where the coefficient of x squared was 1. So we're going to make the coefficient of x squared 1 by taking out a factor of minus 3 from all terms. So I'm going to write minus 3 big brackets. Okay? We're going to use square brackets because later I'll use normal brackets. Maybe you should take out a factor of minus 3 now and write down what you think the expression will look like. If you haven't already, pause the video and do that. Okay, so if you have taken out a factor of minus 3, from all the terms you should get minus 3 big brackets x squared, minus 4 over 3x, minus 5 over 3. Check that you agree with that statement. Notice in the square brackets that we have a quadratic where the coefficient of x squared is 1. This allows us to easily complete the square. Okay. So, we will rewrite x squared minus 4 over 3x as x minus 4 over 6 all squared. Okay, I'm going to rewrite that as x minus 2/3 all squared, and then minus 4 over 9. So we're going to talk about where those numbers came from now. So I know that seemed a bit quick, but we'll talk about where those numbers came from. So how did I get minus 2/3? Well, what I did really is I just halved minus 4/3. So I took minus 2/3 and I halved minus 4/3. Okay? To get that minus 4 over 9, what I did is I squared 2/3. So I squared this term and subtracted. So squaring 2/3 gives 4/9, and I just subtracted 4/9. So that's where those two numbers came from. They didn't come out of thin air. I used that approach. I halved minus 4/3, then I squared 2/3 to get the 4/9 and subtracted it. Okay? I'm going to rewrite this minus 5/3 here. We're going to do a check now just to make sure that what I've written is correct. So if we look at x minus 2/3 all squared minus 4/9, let's expand this bracket, x minus 2/3 brackets x minus 2/3. This gives us x squared minus 2/3 of x minus 2/3 of x, and then minus 2/3 and minus 2/3 is plus 4/9. Okay? So I've expanded the brackets, and I've rewritten that minus 4/9 on the right hand side there. The minus 4/9 cancel with the plus 4/9. Then if I add the coefficients of x, I get x squared minus 4/3 of x. You can see that this now is definitely the same as this. Okay? So the approach that I took, those shortcuts, halving that coefficient of x and squaring that 2/3 to get 4/9 and subtracting it, allows us to complete the square. Okay, next. We can simplify what's inside the square brackets. So x minus 2/3 all squared stays the same. Minus 4/9 minus 5/3, well, minus 5/3 is the same as minus 15/9. Minus 4/9 minus 15/9 is minus 19/9. Now at this stage we've completed the square inside these square brackets, and now all that's left to do is multiply out the square brackets to put it in the form that they've asked for in the question. So expand the brackets, you get minus 3 brackets x minus 2/3 all squared, and then minus 19/3, or plus 19/3, sorry. Okay, so if we look at the question, it wanted us to put it in the form p brackets x plus q all squared plus r. So this minus 3 is the p, so p is minus 3. This minus 2/3 is q. and this plus 19 thirds is r. So that would be the solution to this question. P is minus 3, Q is minus 2 thirds, and R is 19 thirds. Let's imagine now that the question said, hence, solve minus 3x squared plus 4x minus 5 equals 0. Now, of course, we could use the quadratic formula to solve this. We could also use the completed square form, which we've just written, to solve. Okay, so if I write the square form, we can solve this step by step. The first thing you might do is divide by minus 3. So if you divide everything by minus 3, you get this. Okay? Divide the first term by minus 3, you get x minus 2 thirds squared. Divide the second term, you get minus 19 ninths. And dividing the right-hand side by minus 3, you still get 0. You could then add 19 ninths to both sides. At this stage, you could then square root both sides. So if I square root the left-hand side, I get x minus 2 thirds. If I square root the right-hand side, I get plus or minus the square root of 19 over 3. I'll just make a quick side note here. The square root of 19 over 9 is the square root of 19 over the square root of 9, which is the square root of 19 over 3. Okay. Writing this plus or minus the square root of 19 over 9 would have been fine though. Now at this stage you could add 2 thirds and then you get the final answer, x is equal to 2 thirds plus or minus the square root of 19 over 3. So this would be the final answer if we were solving the quadratic minus 3x squared plus 4x minus 5 equals 0, using completing the square. Okay? So the most important parts are how to complete the square. You have to half that coefficient of x, and you have to square what's in that bracket to subtract it. So square this thing here. So these two bits are the most important parts to completing the square. Okay, what I'm going to do now is show you a quick geometric interpretation of this. I think it's interesting. You don't necessarily need to write notes on the next part, but I think it will give you a good feel for what we're doing geometrically. Okay? Also lets us understand what we mean by completing the square. So if you remember from the lesson that we had multi-link in, we could take an expression like this, x squared plus 6x plus 13, and make it into blocks. So x by x blocks is an x squared block, and then lots of x rods here, which are x by 1, and then we could have 13 ones. So what I've drawn here is I've drawn an x squared, I've drawn 6 x's, and 13 ones. Okay, completing the square kind of is what it says. You try and turn it into a square the best you can. So if we take this x squared, okay, now if we take half of our x rods there, we'll have 3 of them lining along this side. And then if I take the other half, I'll line them along the bottom. So I've got an x squared, and then I've got my 6x, I've split it into 2 3's. To complete this square, I need to take 9 away from that 13. So I take these 9, and I put them here. So notice how I have completed this square. Okay? This square you could think about as x plus 3 by x plus 3, or x plus 3 squared. What I have done is I've got those 13 cubes that I started with, those 13 ones, and I've subtracted 9 from those 13. Okay? So this is what I've done, and I've got 4 left over. So really, I could draw these 4 here, and in total I have x squared, x plus 3 all squared, plus an extra 4 left over. So what I've done graphically or geometrically, this is what completing the square is. Before I was just looking at algebraic interpretation of the same thing. Okay, so this is an AdMath topic, as I said. I'll be putting some work on this topic for you to do so you can consolidate this learning. Thank you for watching.